Okay, hi everybody. My name is Frank and this is Aloïs. And we're very excited to talk today about our project Nova AI, which is a conversational AI for language learning. So I'm first going to tell you a bit about the motivation and how we came up with it. So learning new languages is a very important skill in our world today. There are roughly 1.8 billion people that are learning languages, and English is chief among them. And I think many of us can relate to that because, well, we all speak English right now, and many of us have learned it as a second language. And actually, many of us use it every day for work. Among Europeans, 53% use a second language at work. And being able to communicate well in this language is often very important in order to be successful at your job. All right, so languages are important. So how do we learn these languages? So I want you all to think back to how you learned English for the first time. And probably it looked something like this, right? So at school, in a classical classroom setting with textbooks, a teacher in front of you throws vocabulary and grammar at your head until it sticks and you can speak the language. So this is kind of like the brute force approach to language learning, right? And actually, it is quite time consuming. In Germany, in fact, we have up to 10 to 13 years of English classes in school, starting from first grade or third grade. And yet only 42% of students can communicate in English at an intermediate level once they leave school. So clearly something is not really working well here. So the problem is that traditional classroom learning, it is very time consuming. And it is very focused on grammar and vocabulary lists, and it is very passive. And research has studied this, and they've shown for a long time that what's missing, the crucial part, is that in order to be good at speaking in a language, you have to be given opportunities to actively talk in that language. I think this makes intuitively sense, right? The first time you're in a situation where you actually have to speak in a language, that's a whole different challenge. All right, so this is not ideal. So how can we improve this? So technology to the rescue, right? So language learning 2.0, now we have all these apps, Duolingo, Bubble, super easy to get started and learn a new language. So I want a quick show of hands. How many of you have ever downloaded one of these apps or a similar app and started learning a language? Okay, so a lot of hands going up, almost everybody. Okay, great. So follow-up question. How many of you have ever completed a language course in one of these apps? One, actually. Very good. Okay, so one person. So the others, you don't have to feel too bad about this. Actually, informal studies suggest that only around 0.01% of people that start a language course on Duolingo, Spanish, actually finish the course. So 1 in 10,000. So clearly, something isn't working here either. So what's the problem? If you look at it, these apps actually replicate a lot of the mistakes of traditional language learning, which is they're very focused on vocabulary and grammar. They have interactivity, but it is often limited to very specific patterns, like select this card or repeat the sentence. And it's still artificial learning in a vacuum without the natural context and the natural conversational environment. All right, so to summarize the problem, the way we currently learn languages is often inefficient because students are too passive and they're not really encouraged or don't have room to use the language for communication. But actually, modern technology allows us to tackle this problem. There are now these language models like BERT and GPT-3, where you have seen great examples today what they are capable of. They're easily accessible via platforms like OpenAPI or Hugging Face. And they can be used, for example, to generate dialogue like this, which already seems very realistic. And so our idea was, what if we can use these models to simulate a realistic and conversational environment for language learners that they can use to practice? And this was the basic idea how we came up with the project, with the Nova AI project. So our goal, our mission statement was to create an application for a conversational AI that users can talk to and thus gain fluency in their target language. All right, and Aloïs is going to tell you now how we continued from this initiative.
Thanks. Yeah, I'm going to walk you through our process. So once we had our mission statement, we started to invest in our problem defined. We started to investigate which technologies would actually help us solve this problem and what features would be useful to the users. Once we had some ideas, we took part in this innovation workshop here at DSR, which allowed us to break down those features into smaller, manageable parts. We then put them on a feature complexity matrix to see how much effort is needed for each feature and which features can be the most valuable with the minimal effort. And this allowed us to prioritize and to create our roadmap and milestones. So this is what our roadmap looks like. We had 3 weeks to complete the project, so we divided it in 2 milestones. Our first milestone was to achieve a minimal viable product. You can see here our main features was a simple conversation mode, a browser text interface, a basic grammar correction, and we wanted it to be deployed on the server. Once we did this, we moved on to an extended prototype with an extended website, just meaning a more beautiful front end. And then we wanted to focus on making this language learning model really, this model really language learning oriented. And then we added some adaptable language levels, some specific scenarios, and some personas. What does the model actually look like now? So this is our language processing pipeline. When the user chats with Nova, the sentence from the user is first fed into the grammar model. There, the grammar model decides whether there is an error present in the sentence, and if there is, it will output a correction message, and also store information about the error for further analysis and feedback. And then this sentence will be fed into the language model, which then will generate a dialogue response. So you can see here, I go to a movie yesterday. It's corrected into I went to see a movie yesterday, and then the model generates a response. Cool, what movie did you see? Let's go a bit more in depth into our actual models. So for the grammar model, we use a pre-trained model from Hugging Face with Grammar Reformer, which is a GPT-2-based transformer trained on Wikipedia edits, which is trained on grammar detection and correction tasks. You can see on the right side, in yellow are the error types classified, and in green is the error correction. I'll give you a second to have a look. Well, in theory, this is all great, but as you all know, in practice, it's very different. So we actually run into some challenges, and those are 3 of the main challenges that we run into. The first one is that the corrections that the model outputted sometimes were not actually errors. They were more like suggestions for alternative way of saying things. Another issue was that our corrections were not necessarily always the same. So the user could say the same thing twice, and the model could output something different. So once it would tell you there is an error, and once it would tell you there is no error, which can be quite frustrating for a user, right? And our third and main issue was that the model actually was quite strict with the corrections, especially when it came to punctuation errors and capitalization. And per se, those corrections are perfectly valid, but if you are a person who likes to chat, most likely, I imagine you don't really always have a correct punctuation or capitalization. And this in the end really hindered the user experience because it broke the flow of the conversation. So we decided to modify the pipeline of this model in order to just enhance the user experience. What we did is we decided that if there was an error in the sentence of the user and the error was only punctuation capitalization, we would not output a correction message. And then as a failsafe, we also implemented fuzzy string matching, meaning that if the user inputs and the corrected sentence would be similar above a threshold, we would also not output the correction. And this is an example of a proper grammar correction and then generation of further dialogue. Yeah. Let's move on to the language model now.
All right. So for this part, our goal was to create a good conversational response to the input of the user. So first we used a model called BlenderBot. So this is also a GPT-2-based model and specifically trained to be good at dialogue. It was trained on a dataset called the Blended Skill Talk dataset, and the aim for this model was to be especially good at having an engaging conversation and being very empathetic to the users, which is why we chose it also. So here on the left-hand side, you can see an example of what the chat looked like in the first iteration. So you see it's quite a reasonable dialogue. So what we found is that model worked quite well, and it produced good, engaging conversations. It was good at keeping the conversation going, especially, which a lot of language models don't do. And it was fun to talk to. It had a joyful tone. Also good with a dialogue-specific trained model is it has a consistent response format, so we can always rely on it's a good dialogue response. And the model we used had only 400 million parameters, and we could run it on a local machine without much problem. The problem is also it is a very small problem, a very small model, so the quality was so-and-so. It often got stuck in a loop or started contradicting itself. And running a bigger, more powerful version would have been more costly to run and require a GPU and some investment in infrastructure. And also the model had a quite static persona and was not easily customizable without fine-tuning it. So for our second iteration, we decided to switch to GPT-3, which is a lot more powerful. There's 175 billion parameters. And you have seen some of the examples how it is more powerful already today. So I don't want to go too much into depth about the model. So this is kind of just an explanation how we used it. So we always had a base prompt that told GPT-3, basically, this is a dialogue. Please give us a good response. And then we appended the dialogue so far. So for example, the first message from the user here. And then we sent this to the API, generated a response, fed that back to the user, and then got the next input from the user. So this was our call loop. And based on this, our goal was to create 3 conversational modes for our application. So first, we wanted to offer a general conversation, an unguided chat with our Nova AI about any topic you want. Then we wanted to implement scenarios where you could really simulate a specific scenario, for example, shopping in a store or ordering at a restaurant. And in that, Nova then assumes a certain role, like a store clerk or a waiter. And then we also wanted to experiment with personas, where you can chat with a really specific person from history or from fiction. So first, for the general conversation, this is kind of what the base prompt looked like. So we tell GPT-3 this is a conversation between a human and Nova, and she wants to help the user learn English and so on. And here on the right-hand side, you can see an example of what this kind of looks like. So you can see apparently Nova doesn't like Batman very much, but she likes Superman. Yeah. Based on that, one thing we wanted to offer was adaptable language levels. So we found out we could also do that quite well by just modifying the prompts. And a lot of it can be achieved with good prompt engineering. So here, for example, for a beginner level conversation, we told Nova, you speak beginner level English, you use short and simple sentences and words. And for an advanced prompt, we told her, talk in a more complex fashion. And here, for example, you see an example of the advanced chat. And so here you can see Nova asks more questions and has very interesting opinions. Like she thinks Batman is the hero who fights corruption and abuse of power in Gotham City. We can have interesting conversations there, maybe. All right, so this was the general conversation mode. And then also we implemented these scenarios. We implemented 3 different scenarios, buying bread at a bakery, shopping at a store, or ordering in a restaurant. And for that, always told Nova, you are the baker and you sell bread, for example, and here you see one example of this. And and for the third mode, we wanted to implement the personas. And Aloïs will tell you about that.
Yeah, thanks. So first, we thought the prompt works well. Why not try this out that way? So we tried here to implement personas via prompts. In this example, we used Harry Potter. We told the model this conversation with Harry Potter, and then asked who's your favorite teacher and who are your best friends. And you can see that the model knows quite well about Harry Potter, knows that Dumbledore is a teacher, and that Ron and Hermione are the best friends. However, it does not necessarily copy the style of the character, which was what we were intending to do here with William Shakespeare. So we told the model, you are William Shakespeare, and it ended up just outputting just results from the internet about information it had about Shakespeare, which was not super interesting for us if you wanted to really pretend we're chatting with William Shakespeare. So we figured, let's try to do some fine-tuning. I will not go in depth with this because this is the same as the first presentation that you had today. But we fine-tuned GPT-3 on two different models. We tried with Ada and with Curie. Ada is a small, fast model. Curie is a bit more complex. And the way we did this is that we fed it 5,000 lines from Hamlet and Macbeth. And we just saw how it works. So you can see example 1 with Ada, the smallest model. We asked Shakespeare, how are you doing? And the answer looks quite Shakespearean, but it's also nonsense. It just meant nothing. The part that's cut was also nonsense, but it's pretty fun to look at. In the second example, with Curie, the model gets better at dialogue, but we lose a little bit of this format. So we can see in the first model, it was less good at generalizing, which in the end made the formats and I think topics come out a little bit more, but it was just not a nice thing to talk with.
So our goal from the beginning was to really build an application that language learners or users could use for language learning. And so that's what we did. So this is the basic architecture of the application that we have. So at its core, we have a Flask application which have the grammar model and the language model, for which we used first BlenderBot in the first iteration, and then we used the OpenAI API. We have a database where we store some user info from authentication and so on. And then the whole thing was deployed as a Docker image on an AWS EC2 server. And the user can access our application via web interface. So this was kind of what the first version looked like. And we had that up and running at the MVP stage. So this was just a bare bones application with a general chat for us to test something. So there's some random stuff in there now. And then after the first iteration, we wanted to redesign the front end and make it a really good application. So we did an outline of the sitemap. We thought about the user flow and how a user would use the website. We designed some wireframes for the different parts of the website, like the main dashboard, what the chat should look like. And yeah, based on that, we implemented this. And now we're going to do a live demo. So our application is online at nova-ai.net. So go there, try it out. So this is kind of what the landing page looks like. We have some information about the app, what the features are that we offer. All right, and when you click on Get Started, you're redirected to the user login. So it was important for us to be able to offer a user personalized, customized experience. So that's why we implemented this. So here you land on your dashboard, which shows you some of your recent progress and also suggests something to do in the app. If you go to learning statistics, you can see more about your learning progress. So the recent sessions you had. And here, for example, we show the grammar because we can store info about what things you're struggling with and show you feedback here. And based on that, also suggest some next chats that you could do, for example, here. All right, so let's go to all chats. So these are all the chats, conversation modes that we've implemented. So at the top, you see the general conversation mode, the unguided chat at 3 different difficulty levels. Then below that, we have the 3 scenarios that we implemented, and then our Shakespeare persona so far. So if we go to one of the scenarios, maybe the bakery, just to show the interface. So that's kind of what it looks like. Here on the side, you see a small description about what the scenario is. And then something we found out, it's good if we add some goals that the user can achieve and try to achieve in the conversation. For example, buy 6 slices of bread. And that gives them something to do. In a later iteration, this could also be detected from the user text, whether they have really achieved that. All right, and now we're going to try it out. We're just going to go to the intermediate chat. So you can see Nova always starts with something like, hey, how's it going? And so on. And now, Aloïs is going to tell her that we're talking about her. Right, so and once you click send, this gets fed through the grammar model, sent to GPT-3, and Nova is happy that we're talking about her. Which kind of pizza was ordered? Oh, that's interesting. Maybe she'll know that no pizza was ordered. We should order pizza. That's a good suggestion. Yeah, let's tell her to order pizza. I'm sorry, I don't understand. So back to the plan. So this was our road so far, and we just want to give a quick outlook what we could do next. So we want to further improve the dialogue quality. As we saw, there are some kinks that could be leveled out. We would also like to try the BlenderBot model again, or our dialogue-specific model again, because we've also got good results there. The tracking of grammar errors we haven't yet fully implemented. This was more like a mock-up that you saw, but we could store these errors and show them to the user. We want to implement user goals and ranks and more of the learning path system so that you can really use it to learn. And for that, also, we want to add more scenarios and more personas. We also really wanted to implement a speech interface because that would be a really great experience to not have the chat, but also actually be able to speak. And then we want to extend it to other languages so that it's not just for English learning. All right, so again, the application is online here. Go there, make an account, try it out. We also have the full code for the application available on GitHub, so you can also look at that if you're interested in this. And here are our contact details. If you have any questions or wish to contact us,